Alright, in this video, I'm going to break this lesson actually up into 5 parts, and what the purpose of the lesson is going to be to show you, the whole lesson is going to be to show you how to simplify expressions involving exponents. So when you simplify them, make them simpler, and they're all going to have exponents in them. Here's some examples of what we're going to be looking at, something like this: x to the fourth to the third power, or y to the cubed times y to the fifth, and so on. You can see all of them there. We're going to eventually get through all of them. I'm going to go through them 5 different rules for solving these 5 different kinds of problems one at a time. It's 5 rules. It is a lot of rules, but as I'll emphasize over and over again, the main thing you want to be able to do is remember the strategy that I use for finding the rules. This is a strategy that I'll employ each time. If you can remember that, you'll be able to figure out the rules yourself even when you forget them, which you will because everybody does. Okay, so this is the first one I'm going to look at. The first rule is called the product of powers. So we're given something like this: simplify x cubed times x squared. Now, the first thing I want to note is that we've got x cubed times x squared. Both of these are the same variable to different powers, and we're multiplying them together. Product, right, means multiplication. So we've got the multiplication symbol in there. Okay, so we are asked to multiply x cubed times x squared. Well, first, let's just remind ourselves what these mean. What is x cubed? Well, it's just x times itself 3 times, or x times x times x. And then x squared, obviously, is just x times itself. X times x, 2 x's, right? Not the same as 2x, that would be 2 times x, but x squared is x times x. Okay, so then if what we have is x cubed times x squared. All right, so x cubed, we just said, is x times x times x, and x squared is x times x, and we're just multiplying them together. Here we have, that's x cubed, right? And then over here we have x squared, and all we're doing is multiplying the two of them together. All right, so x cubed times x squared. We've got x. What do we end up with now? X times x times x times x times x, or x times itself 1, 2, 3, 4, 5 times, which is x to the fifth. Well, what did we do then? Well, we started out with x cubed and x squared, multiplied them together, and we end up with x to the fifth. Well, how do we go from 3 and 2 to 5?
Please excuse us.
So we have, how do we go from 3 and 2 to 5? Well, obviously that's addition. 3 plus 2 equals 5. And that makes sense that this is how it would work out, right? Because we have x cubed times x squared, so we're taking these 3 x's and then these 2 x's, and we're multiplying them all together. So 3 x's plus 2 x's, we should end up with 5. And that gives us a more general rule. X to the m, some power m, times x to some power n is going to equal x to the m plus n. Notice again, notice that got the same variable here again, x and x in both cases. That's the only way it's going to work. We end up with x to the m plus n. Let's look at some examples to see how this works. Well, x to the fourth times x to the sixth. Same variables here, so we can use this rule, right? X and x. X to the fourth times x to the sixth, that should be, according to our rule, x to the 4 plus 6 power. 4 plus 6 is 10, so we should end up with x to the 10th power. And even if you don't write it all out, you might want to think back in your head, well, what does that mean? That means x times x times x times x, right? Times x times x times, I get bored of writing it, but there's going to be 10 of them, right, over here. So I've got 10 x's here and 4 x's here, right? Oh wait, no, sorry, 6 x's. My bad. Right, so we got 6 x's here, so we got 4 x's times 6 x's, so we should end up with how many we're going to have all together. We're going to have 10 of them, right? Or x to the 10th. Same thing here. Z to the 10th times Z cubed, or Z to the third power rather, that's going to be Z to the 10 plus 3 power. All right, Z 10 plus 3 is 13, so we end up with Z to the 13th. So Z to the 10th times Z to the third is going to be Z to the 13th. And again, it doesn't matter if we're using variables or numbers as long as they're the same one, right? As long as we got the same base there, 3 and 3. So we got 3 to the 5th, 3 squared. So we can imagine a bunch of 5 threes, and then 2 more, 3 to the 5 plus 2. So that's going to be 3 to the 7th. All right? So that's how the rule works. One important point, I know I've emphasized it a couple times, but just to say it again, the rule requires that the bases be the same. All right? The bases, by the bases I just mean, this is the 3's here, the number that has the term that has the exponent. Z's here, the X's here, or if we look at our rule, X to the M, X to the N. In order for us to use this rule, we need to have the same bases. So one thing you'll see sometimes, you'll see something like this. Well, X squared times Y cubed. And you'll think, oh, is that X, Y to the 6th? Or is it maybe X to the 6th, Y to the 6th? Well, I'm not sure. Or something like that. No, it's none of these things. You know what it is? It's just X squared, Y cubed. There's nothing I can do. There's nothing I can do to simplify that any further without knowing what X and Y are. I just have to leave it like this, X squared, Y cubed. All right, there you go.